So what if an AI could spot a disease that causes blindness? Not just as well as a human expert, but maybe even better. And what if it could do it in a fraction of the time? Well, let's get into it, because a new study has just unveiled an AI model that could be a huge leap forward in the fight against one of the world's leading causes of vision loss. First things first, let's talk about what's at stake. What you're looking at here are images of the back of the eye, showing how diabetic retinopathy progresses from a perfectly healthy eye to one with really severe damage. This isn't just some minor issue. It's a direct complication of diabetes, and it's one of the fastest-growing causes of blindness on the planet. So, what is this thing exactly? Well, diabetic retinopathy, or DR for short, is what happens when high blood sugar starts to wreak havoc on the tiny, delicate blood vessels in your retina. Over time, that damage can cause them to leak, swell up, or even grow where they shouldn't, and that's what eventually leads to vision loss. You know, the really scary part about DR is that it's a silent threat. In the beginning, in the early stages, you might not have any symptoms at all. By the time someone actually notices that something's wrong with their vision, a lot of serious, sometimes irreversible, damage might have already been done. That's why catching it early is everything. And we're not talking about a small problem here. The scale is, well, it's staggering. Globally, the number of cases is expected to explode to nearly 200 million by 2030. That is a massive public health crisis just waiting to happen, and it puts an incredible strain on healthcare systems everywhere. So, the way we do it now, a highly trained specialist has to sit down and manually look at these eye scans, called fundus images. But that whole process is a major bottleneck. It's slow, it takes years and years of training to get good at, and honestly, even for the experts, it can be subjective. We just desperately need a better, faster way. And that better way just might be AI. So how in the world do you teach a computer to see a disease like a seasoned doctor? Well, you pretty much send it to medical school. But instead of textbooks and lectures, you give it a gigantic data set of images to study. For this particular study, the researchers had a really clear three-step game plan. First, they gathered thousands of these retinal images. Second, and this is key, they cleaned them up and enhanced them to make sure they were crystal clear for the AI. And finally, they trained their model to sort those images into one of 5 stages, from totally healthy to the most severe stage of the disease. Now, check this out. This is the first part of that cleaning process, the pre-processing. Just look at the difference. The image on the left, the raw one, it's full of all this visual static or noise. The researchers used a special filter to basically scrub it clean, which gives you the much clearer image on the right. It's like wiping a really dirty window before you try to see what's outside. Okay, so the window is clean, but that's not enough. You also need good lighting. That was the next step, enhancement. You can think of this like adjusting the brightness and contrast on a photo, so the really important details just pop. You see in the after image, the blood vessels, all the little features, they become so much more distinct. It gives the AI a much, much better view of what's really going on in there. Then they did something that's kind of like the secret sauce for training a really smart AI, data augmentation. They took their starting data set of about 3,600 images, and by doing things like digitally rotating and flipping them, they more than doubled it to 7,500 images. This is so important because it teaches the AI to recognize the disease no matter the angle or orientation, making it way more robust. All right, so with their data all prepped and ready to go, the researchers didn't just test out their own new custom-built model. Nope. They staged a full-on technological showdown. They put their creation, which they called DRNet13, up against 15 other well-established, pre-trained AI giants, a real battle royale. And this was the big question, right? Could their brand new, leaner model, the new kid on the block, actually beat some of the most famous, most powerful architectures in the entire world of computer vision, things like GoogleNet and VGG19, at this one very specific, very critical task? So after putting all 16 models through the exact same tests on the exact same dataset, what happened? Well, the results were, let's just say they were pretty darn clear. One model absolutely stood out from the rest of the pack. And this chart just says it all. The new model, DRNet13, hit a stunning 97% validation accuracy. I mean, it didn't just win, it significantly outperformed the next best competitors, which were all stuck down around 93 or 94%. In medical diagnostics, a few percentage points like that, it's a huge deal. So let's just focus on that number, 97%.
To be that accurate in correctly identifying the different stages of this disease, that is a massive step forward for any kind of automated tool. But believe it or not, accuracy was only half the story.
Because here's the real kicker. DRNet13 didn't just win on accuracy, it completely crushed the competition on speed. Look at this! It took only 150 minutes to run its tests. That's almost twice as fast as many of the other models. It wasn't just the smartest AI in the room, it was also the fastest. The researchers themselves put it perfectly. They said their model achieved an optimal balance between accuracy and computational efficiency. And really, that's the holy grail in AI development, right? You want something that's both incredibly smart and incredibly fast. They nailed it. Okay, so great. We have an AI that's faster and more accurate. But what does that actually mean? For doctors, for patients, for the future of how we diagnose eye diseases? Well, the implications are actually pretty profound.
This is one of my favorite slides because it gives us a peek inside the AI's brain. These are called feature maps, and those bright yellow areas show us exactly what the AI is paying attention to. You can see it's learning to completely ignore the background noise and just zero in on the specific patterns, the little hemorrhages and aneurysms that are the dead giveaways of the disease. And that efficiency, that speed, it's a total game changer. For patients, it could mean getting a diagnosis way faster, and that is absolutely critical for starting treatment early. And for clinics, it means this kind of AI could potentially run on less powerful, cheaper computers, which would make it accessible even in more remote areas. It could completely change who gets access to top-tier diagnostics. Now, of course, no model is perfect, and the researchers are very open about that. These here are a few examples of images the AI got wrong. And usually, it was because the image was right on the borderline between two stages of the disease, the kind of cases that are tough even for human experts to call. But understanding these mistakes is exactly how you make the next version of the AI even better.
So, all of this leads us to one final, really exciting question. The technology is here, and we've seen it's incredibly effective. So how soon could an AI assistant like this one actually be in your local eye clinic, working right alongside the doctor to help save people's sight, not just here, but all over the world? The future of diagnostics might be a lot closer than any of us think.